So, let's go. NASA tracked a spacecraft down to the millimeter per second, and something out there gave it a free speed boost that 35 years of physics still can't explain. That's just number one. Number one, the free speed boost. In 1992, a spacecraft called Galileo swung around Earth to pick up speed on its way to Jupiter. Standard gravity assist, the kind of maneuver mission controllers had done dozens of times. You use the planet's gravity to slingshot the craft forward, you gain velocity, you continue on your way. Textbook. Predictable to absurd precision. And then the numbers came back wrong. Galileo was going faster than it should have been. Not dramatically faster, we're talking about millimeters per second. But NASA's tracking network is so sensitive that millimeters per second is a screaming anomaly, not a rounding error. And for a craft called NEAR, the discrepancy was 13 millimeters per second. Tiny number. Except tiny numbers compound. Over the course of 1 week, that drift puts the spacecraft 8,000 kilometers from where the math said it would be. That's not noise. That's roughly the width of a continent, twice, of pure unexplained deviation. So they checked again, and again. And then other spacecraft did flybys: Galileo, NEAR, Cassini, Rosetta. Every single Earth flyby logged an energy change nobody could account for. Some gained energy, some lost it. The anomaly changed sign depending on the geometry of the pass, and two separate researchers built two separate empirical formulas that predicted it, using only the spacecraft's latitude at closest approach as input. One variable, no physical mechanism, just a pattern that fits. Here's the strangest part. The effect only shows up in Earth's reference frame. Switch your coordinate system to the sun's frame of reference, and the anomaly evaporates. It's like something specifically about Earth, or about how Earth sits in space, is doing this, and we don't know what that something is. Then Rosetta came back for a second flyby, and the anomaly was gone. Same spacecraft, same planet, different geometry, and the formula predicted that too, predicted the null result. A formula with no physics behind it, predicting both the effect and its disappearance. 35 years, multiple missions, still open. Something is quietly playing with momentum around this planet, and it's doing it on a schedule that matches a pattern we can describe but can't explain. Keep that in the back of your head. We're coming back to it. Number 2, the anti-gravity we already confirmed. In 1998, two completely separate teams of astronomers were racing to do the same thing, measure how fast the universe was slowing down. Not whether it was slowing down, that wasn't even a question, of course it was slowing down. The Big Bang threw everything outward, and gravity has been pulling it back together ever since. The only open question was how fast the brakes were working. They weren't working. The universe wasn't slowing down at all. Both teams were measuring the brightness of distant supernovae, a specific type of stellar explosion that always detonates at roughly the same intrinsic brightness, which makes them useful as cosmic distance markers. And the supernovae were dimmer than they should have been. Not slightly, consistently, measurably, unmistakably dimmer, meaning they were farther away than expected. Way farther. The universe wasn't just coasting after the Big Bang, something was actively pushing it apart. Still is, right now, at this moment. Accelerating the expansion like a foot pressing harder on the gas. They called it dark energy. It makes up 68% of everything that exists in the cosmos, and at large enough scales, it wins. Gravity pulls together. Dark energy pushes apart. And dark energy wins. That is the definition of anti-gravity, not a fringe theory, not a lab anomaly. A Nobel Prize-winning, independently confirmed cosmologically dominant force that overpowers gravity across the universe. When someone asks if anti-gravity is possible, the truthful answer is, it's already here. It makes up most of reality, we just can't access it in a useful way. Yet. Now here's where even the confirmed science gets uncomfortable. The leading model says dark energy comes from the vacuum, that empty space itself has energy, that actual nothing exerts outward pressure. And there's a real experiment that proves the vacuum does something. Put two metal plates very close together without touching them in a sealed chamber, and they'll be pulled toward each other. Nothing is pushing them. No air, no fluid, no field you injected. Quantum fluctuations in the space between them create a pressure difference that physically moves the plates. You can measure the force. It has a name, the Casimir effect. The vacuum is real, and it does things. The problem is the math. When physicists calculate how much energy the vacuum should have, the number they get is somewhere between 60 and 120 orders of magnitude larger than what we observe. That's not a small discrepancy. That's a number followed by up to 120 zeros, too large. It's been described as the worst theoretical prediction in the history of science. So, we've confirmed anti-gravity exists, we've confirmed the vacuum does something, and we have a prediction that's so catastrophically wrong that it tells us something fundamental is missing from the picture. The universe is expanding faster than it should, powered by something we can measure but can't explain, at a scale that makes the math break. Zoom in from cosmic scale to galactic scale. It doesn't get better. Number 3, gravity breaks at the edge of galaxies. Picture a solar system. Planets close to the star move fast. Planets far from the star move slow. Mercury's sprinting. Neptune is barely shuffling. The further you get from the central mass, the weaker the pull, the slower the orbit. That's been true since Newton wrote it down. It held up when Einstein rewrote all of physics. It's one of the most tested relationships in science. Now picture a galaxy, billions of stars, enormous central mass, dust and gas spiraling outward, should work exactly the same way. Stars near the core fast, stars near the edge slow, a smooth gradient falling off toward the outer rim. In the 1970s, an astronomer named Vera Rubin measured the rotation speeds of stars across thousands of galaxies. And the outer stars weren't slowing down. They were orbiting at the same speed as stars near the center. Every galaxy she looked at. Not most of them. All of them. The outer stars of a galaxy were moving so fast that according to every physics equation we had, they should have been flung off into intergalactic space billions of years ago. The galaxy should have torn itself apart. But it hadn't. It was just sitting there, rotating calmly, like the laws of physics had agreed to do something different past a certain radius. 2 explanations have been fighting for 50 years and neither has won. The first says there's invisible matter wrapped around every galaxy in a vast halo. Stuff that doesn't emit or reflect light, doesn't interact with anything we can detect except through gravity, and exists in quantities large enough to provide the missing pull that holds the outer stars in. We call it dark matter. We've never directly detected a single particle of it. The second explanation says there's no invisible matter, there's something wrong with gravity itself. That below a certain acceleration threshold, a number so small it's roughly the gravitational pull at Neptune's distance from the Sun, gravity stops following the inverse square law and starts behaving differently. Stronger. This idea is called MOND, Modified Newtonian Dynamics, and a physicist named Mordechai Milgram proposed it in 1983. What makes MOND uncomfortable to dismiss is that it made a prediction before the data existed to test it. It predicted that a galaxy's outer rotation speed should scale with the 4th power of its total mass, a very specific mathematical relationship. That relationship was confirmed in the data. It wasn't fitted to the data. It was predicted first, then found. That's how science is supposed to work. A paper in 2024, it tracked rotation curves past the point where stars even exist, out into the bare darkness at a galaxy's edge where there's nothing but emptiness. The curves stayed flat. Mondi predicted that. Dark matter, or modified gravity. Pick your nightmare. One says the universe is mostly made of stuff we can't see and have never detected. The other says our foundational equations for how gravity works are wrong past a specific threshold, and we've been using broken math for 2 centuries without realizing it. We've known something is wrong here since 1970. The argument is still running. Number 4. The superconductor that broke the scale. In 1992, a physicist named Evgeny Podkletnov put a ceramic disc in a cryogenic chamber, cooled it to liquid nitrogen temperatures, and spun it up to 5,000 rotations per minute. Then he suspended a test mass above it and measured the weight. The object above the disc was lighter than it should have been, not dramatically, between 0.3 and 2% of its weight, depending on the run. That sounds small until you do the comparison. Commercial aircraft don't reduce weight by 2%. Engineering feats that took decades to achieve don't reduce weight by 2%. A spinning cold ceramic disc in a lab doing it spontaneously is not small. And the result was published, peer-reviewed, in a physics journal, not on a forum, not in a press release, in the literature. What came next was a decade of failed replications. Multiple institutions tried and got nothing. The explanation offered was always the same. The ceramic, a material called YbCO, had to have a very specific internal grain structure to work, and nobody outside of Podkletnov's original setup had gotten it right. He maintained this consistently. He still maintained it as of 2025. Here's the detail that keeps this entry alive. Boeing took it seriously enough to fund a classified research program called GRASP, Gravity Research for Advanced Space Propulsion. They wanted to verify the effect and potentially develop it. The program was stopped by restrictions on Russian technology transfer before it produced results. A major aerospace corporation didn't look at this and dismiss it. They looked at it and tried to build something. The scientific consensus position is that the effect is unverified and probably not real. That's accurate. But the honest position is more uncomfortable. The effect was not disproven, it was not replicated, and those are different things. Failed replications with a poorly understood material are not the same as a controlled refutation. Every entry before this one was about anomalies we stumbled across passively. Spacecraft getting unexpected boosts, galaxies rotating wrong, the universe accelerating. And this is the first entry where a person sat down, built something deliberately, and claimed to manipulate gravity. And the establishment's answer wasn't proof that it didn't work. It was an inability to make it work. That's a different kind of uncertainty. Number 5, the ESA experiment that shouldn't work. This one took 3 years, 250 separate experiments, and 8 additional months of deliberation before the team was willing to publish anything. The setup was a spinning superconducting ring. According to general relativity, any spinning mass drags space-time slightly as it rotates, a real effect called frame dragging that exists and has been measured. But in a lab, with a small ring, the predicted magnitude is so close to zero that it's essentially unmeasurable. You'd need something the size of a planet to get a detectable signal. The instruments on this experiment read a gravomagnetic field roughly 100 quadrillion times larger than general relativity predicted. Read that again. Not twice as large. Not 1,000 times. 100 quadrillion. The kind of number that makes physicists sit in silence for 8 months before saying anything, because the only two explanations are the experiment is wrong and we're missing something enormous about how physics works. The lead researcher went through every possible source of error: electromagnetic interference, mechanical vibration, sensor artifacts, calibration drift. 250 experiments systematically eliminating explanations, and then the team published anyway because they couldn't find the error. What gives this anomaly deeper roots is a separate, older mystery. Niobium superconductors, the material used, contain electron pairs that have been measured as slightly heavier than quantum theory says they should be, 84 parts per million heavier. That result has been sitting in the literature since 1989 with no explanation. It's not dramatic enough to make headlines, but it means there's something about the quantum behavior of superconductors that our models don't fully capture. Later follow-up work found that part of the signal shrank when specific accelerometer errors were corrected. The team never claimed their original result was completely wrong. They published the correction. The gap between partially explained by equipment error and fully explained by equipment error is still open. No independent lab has reproduced the signal. No independent lab has cleanly eliminated it. The number that came out of that experiment should not exist. It might be an artifact, but it has never been fully killed. Number 6, the Nobel laureate's pendulum. Maurice Allais won the Nobel Prize. Not in physics, in economics. But he was also one of the most meticulous experimental physicists of the 20th century. And he spent decades trying to tell the scientific community that gravity briefly changes during a solar eclipse, and being mostly ignored for it. In 1954, during a total solar eclipse over France, Allais was running a precision pendulum, a device sensitive enough to track the Earth's own rotation through the slow drift of its swing. During totality, as the moon slid fully across the sun and the sky went dark in the middle of the day, the pendulum drifted several degrees off its predicted path. Not a tiny drift. a real observable deviation from where it was supposed to be. Then the eclipse ended, and it went back to normal. He saw the same thing in 1959. He replicated it himself with a different instrument under different conditions. Same result. The effect is named after him, the Allais effect, and it's generated controversy ever since. During the 1997 eclipse, gravimeters operated by researchers in China recorded two distinct dips in local gravitational strength. The dips happened at the precise moments of first and fourth contact, when the moon's edge first touched the solar disk and when it finally separated. The moon's own gravitational pull can't account for them. The geometry of the alignment should be irrelevant to gravity, but there it was. NASA organized a coordinated multi-country test for the 1999 eclipse. 7 countries. Multiple instrument types. The results were never published. The lead supervisor described what they found as, and this is a direct quote, a systematic error, a local effect, or the unexplored. That last category is doing a lot of work in 3 words. A paper published in 2024 proposed that the anomalies in nighttime eclipse observations were caused by electromagnetic interference from industrial power systems, factories, and grids active during what those systems experience as ordinary night, while eclipse observers measured their instruments in the moon's shadow. It's a plausible and somewhat deflating explanation. The debate is still running. What Allais was proposing is that the alignment of the sun, the moon, and the earth briefly modifies gravitational strength at the surface. If that's true, eclipses are physics experiments on a schedule we didn't set. If it's wrong, this is what it looks like when a brilliant, rigorous mind falls so completely in love with a result that it stops being science and becomes a belief. After 70 years, we still don't know which one it is. Number 7. Build it in your garage. This is the only entry on this list you can test tonight. Aluminum foil, balsa wood, a spool of thin wire, a power supply pushing about 25,000 volts. Assemble it into a triangle. Thick foil conductor on the outside, thin wire on the inside, a gap between them. And when you flip the switch, the thing rises. Silently. No engine, no propellant, no moving parts at all. A faint purple corona glows along the wire. There's a faint smell of ozone, that sharp electric smell like air after lightning. And the device just lifts. These are called lifters. They've been built by hobbyists and researchers for decades. They're not secret, not classified, not expensive. The mainstream physics explanation is called electrohydrodynamics. High voltage ionizes air molecules near the thin wire, turning them into charged particles. Those ions get accelerated toward the thicker conductor, collide with neutral air molecules on the way, and the resulting stream of moving air pushes back against the device. Thrust. It's essentially an ion wind pump. Elegant, explainable, nothing exotic. And it works in air. In vacuum, the effect disappears. Multiple experiments have confirmed this. The consensus is ion wind. Case closed. Except, in the 1950s, the original discoverer of this phenomenon, a physicist and inventor named Townsend Brown, conducted vacuum tests at a military testing facility in France, funded by the French government. He reportedly observed persistent thrust even with no air present to ionize. Those results were never published, never independently verified. They exist as a story about an experiment, not as a paper you can read. And even under the fully mundane electrohydrodynamic explanation, something interesting turns up in the numbers. Measured thrust efficiency for these devices runs around 68 newtons per kilowatt. The best ion drives currently operating in space, precise, expensive, cutting-edge propulsion systems, produce roughly 20 newtons per kilowatt. Aluminum foil triangles in someone's living room are outperforming spacecraft engines by that metric. Whether that's because of something mysterious or just because atmospheric ion interactions are more efficient than vacuum plasma, nobody is fully worked out. You can build this for $50 and watch something rise with no moving parts and no exhaust. Maybe it's just interesting engineering. Maybe the guy who first noticed it in the 1920s was looking at something stranger. The effect is real. What it means is still, genuinely, not settled. Number 8, the universe is expanding wrong. There are 2 completely independent ways to measure how fast the universe is expanding. They use different physics, different instruments, different parts of cosmic history, and different mathematical frameworks. They should give the same answer. They don't. Method 1 reads the cosmic microwave background. the faint afterglow of the Big Bang that permeates all of space, a relic signal from 380,000 years after everything began. It gives an expansion rate of 67.4 kilometers per second per megaparsec. Method 2 measures Cepheid variable stars, stars that pulse at a rate tied precisely to their brightness, making them reliable distance markers, and combines them with supernova observations. It gives 73 kilometers per second per megaparsec. That gap is 5.5 units, and the statistical confidence behind it is greater than 5 sigma, which in physics is the threshold you need to announce the discovery of a new particle. This isn't a measurement you average away, this is a crack. The James Webb Space Telescope was designed partly to resolve this tension. It launched. It looked at more Cepheids than any previous instrument, more precisely, with better calibration. The local number held. The confidence level went up to 8 sigma. JWST made the problem worse, not better, 8%. The universe is expanding 8% faster than the standard model says. It should be able to. At cosmological distances, that's not a rounding error. It means galaxies are sitting billions of light years further from us than theory places them. The entire map of the large-scale universe might be drawn wrong. Every serious proposed solution requires physics that doesn't exist yet in any confirmed form. Dark energy that changes over time instead of staying constant. Gravity that behaves differently across enormous distances. Some unknown component that dominated the early universe and then vanished without a trace. In 2024, a major sky survey called DSC released data hinting that dark energy might not be a fixed property of space, that it's been slowly weakening since the Big Bang, that it's dynamic, that something is changing. The earlier anomalies in this list were cracks in specific experiments. 1 spacecraft, 1 lab, 1 observatory. This one is a crack in the framework. Those experiments all live inside. The model that's supposed to contain and explain all the other anomalies, that model doesn't add up to the universe we're actually measuring. And here's where it connects back. Number 9, the impossible thruster. In 2016, a paper claiming a propellantless thruster worked past peer review and triggered the most chaotic 5 years in experimental aerospace in recent memory. The device was a sealed metal cone. Microwaves bounced around inside it. According to every principle of physics, this should produce nothing. No net force, no thrust, no movement. Thrust requires exhaust. Something has to leave the vehicle. Newton's third law is not a suggestion. The device had nothing leaving it. NASA's experimental propulsion lab tested it in near vacuum conditions and measured a consistent thrust signal of 1.2 millinewtons per kilowatt. Small, but real and repeatable. The methodology was reviewed. No obvious error was found. It was published. The internet lost its mind. If the effect were real and scalable, Mars in 70 days. No fuel. No resupply missions. A spacecraft that could run indefinitely on solar power alone. Then a team in Germany ran a more controlled version of the experiment with better instruments. They found the mounting hardware was thermally expanding during operation, the test chamber warping slightly from heat. That tiny physical distortion was registering as thrust. When they redesigned the geometry to account for it, the signal disappeared. The EmDrive failed. That's the honest accounting of where this sits. But here's what the failure is pointing at. The team at NASA's lab, trying to explain the anomalous signal before they knew it was an artifact, proposed a mechanism. The microwaves might be interacting with quantum vacuum fluctuations. Pushing off empty space the way the Casimir plates get pushed together by fluctuations in the gap between them, using the vacuum as a reaction mass that's simultaneously everywhere and costs nothing to use. That mechanism was not disproven by the thermal correction. Only the experiment was wrong. The quantum vacuum is still doing something. We showed you that in section 2. The vacuum pushes plates together. Dark energy is a vacuum pressure. The physical behavior of nothing is genuinely strange and genuinely real. The EmDrive pointed at that. It was wrong about its own thrust. It may have been right about where to look. Number 10, the math that shouldn't fit. Come back to the Flyby anomaly. Because there's one detail about it that tends to get buried, and it's the most unsettling part of the whole list. The formula that predicts the flyby energy boost uses one variable, the latitude of the spacecraft at closest approach to Earth. That's it. One number goes in, the predicted anomaly comes out, there's no force law behind it, no physical theory it's derived from, no model of gravity or electromagnetism that generates it. It's a pure empirical fit. A pattern found in the data and expressed as a formula, with no explanation for why that pattern exists. It predicted the Rosetta anomaly. It predicted the null result when Rosetta's geometry changed. A second researcher built a different formula, using different assumptions, and it also fit the data. 2 formulas. No physics. Both correct? Now here's the thread that pulls the whole list together. The acceleration scale at which the flyby anomalies occur, tiny at the edge of what's measurable, is very close to the critical threshold in Monde where gravity stops behaving normally. That threshold is about 1.2 times 10 to the negative 10 meters per second squared. And that number is tantalizingly, suspiciously close to the speed of light multiplied by the Hubble constant, the number that describes the expansion rate of the entire universe. Milgram noticed this. McCulloch noticed it. The connection has been sitting in papers for years, mentioned carefully, without anyone claiming to understand what it means. But think about what you've just watched across 10 entries. Spacecraft gaining unexplained energy near Earth at a specific acceleration scale. Galaxy rotation curves breaking down at the same acceleration scale. The universe expanding at a rate that doesn't match its own history. A cosmological constant nobody can explain the size of. Vacuum energy that does measurable things in labs and might be powering the expansion of the cosmos. Lab experiments that produced gravomagnetic fields a quadrillion times larger than Einstein allows. These aren't 10 unrelated strange events. They might be 10 different instruments all measuring the same gap from different angles. A hole in the physics visible from Earth's orbit and from the edge of observable space simultaneously. And we've been naming each measurement separately without asking if they're all pointing at the same thing. We haven't confirmed antigravity, but we've measured something that behaves like it at the scale of the entire cosmos, watched spacecraft get pushed by forces with no known source, found lab signals that shouldn't be possible, and noticed that 3 completely separate anomalies keep returning the same impossible number. The math keeps pointing at the same gap, we just haven't figured out what's on the other side of it yet.